Science Energy Test B. Please excuse the dirty paw print. And we're going to look at page 1 here. So questions 1, 2, 3, 4, and 5. So the first part, you just had to do some matching. And so on this matching section, we've got first thermal energy, non-mechanical. Kinetic energy is mechanical. Solar and nuclear are both non. Chemical and electrical are both non. And then we've got gravitational potential and elastic potential. Those are mechanical energy. A quick way to just think of, is it mechanical, is it not mechanical, is can you see it? Then it's probably mechanical. Can't see it, it's probably not mechanical. I know, like, if we think about thermal energy, you might think, well, I know there's like a delay. Sorry. It's weird. But anyway, when you think about thermal energy, you can think about being able to see the heat. You can see fire, perhaps, but we can't really see heat. You might think about in the summer, you can sometimes see like the sky looks a little hazy, like when there's, or like over the blacktop, you can kind of see the heat waves coming off. But that's getting a little bit like too technical. We're just thinking in general, can you see heat? Not really, no. Can you see kinetic energy, motion? Yes, we can see things in motion. Can you see gravitational potential energy, lifting something up? Yes, we can see that. Can you see elastic potential energy, squeezing the binder clip? Yes, we can see that it's squeezed and we can see when it springs back together. So those are things we can see. That makes that's an easy way to tell that they are. Then we've got the matching section. Windmill blades, that is something in motion, so that is going to be kinetic energy. A box being lifted off the ground, that is going to be gravitational potential energy. Cell phone charging, electrical. Pulling an arrow back, that is going to be elastic potential energy. And then the process that powers the sun, that is nuclear energy. And finally, what you have after eating a sandwich is chemical energy. The TE in this formula stands for total energy. It's these things added together, and so that's going to be the total. Joules is the SI unit for both work and energy. I saw a lot of people put down work in power or energy in power. Power is actually the rate that energy is being used, or the rate that work is done. And so that's actually going to be in joules per second as watts. So what I'm looking for here is work and energy. Some people did put mechanical energy and non-mechanical energy, or kinetic energy and potential energy. And so as long as you had energy in there, I gave you 1 point, but I needed to have both work and energy for the 2 points. The last question on here is the example of convection, and I just really was impressed with this drawing here that the student did of a convection oven. Not only telling me that this is a convection oven, but also showing with the arrows how the air inside of a convection oven, you get that cycle, that rotating motion, and it's the heat that's rising and the cool that is falling. And so another student had this hot air balloon, which I really liked. And this shows there's the flame, and then also illustrating that the hot air rises and the cool air falls. And so that creates a convection current, and so we have motion happening. So that was really good. Okay, that's page 1.